Hello. Hey. How's it going, everybody? Welcome to NSMeetup April. Welcome. Had a nice sunny day here in San Francisco. How many first-time NSMeetuppers do we have here tonight? Quick show of hands. Wow. All right. Welcome. Let's give a round of applause for the newbies here. If you don't know, NS Meetup meets right here every first Wednesday of the month. Talk about iOS, open source, programming topics. There's plenty of beer. There's Coke. There's water. There's beer. There's even a few snacks over there. Also, if you need to use the restroom, it's just past the elevators where you came in down the hall. Also, I want to thank our host, Amazon Music. So can we get a quick round of applause for the Amazon Music team? Dave in the back there is from Amazon Music. If you guys want to ask him any questions, he'll be bouncing around. We got a great speaker for you tonight. If you're ready to have some fun with instruments, I'd like to introduce Doug Suriano.
What's up, everybody? Okay, cool. So, welcome to Fun with Instruments. So, I'm super excited to be here. But first, just really quickly, a little bit about me. As Steve said, my name is Doug Suriano, and I am an iOS engineer over at Hotel Tonight. Hotel Tonight is a last-minute booking app. Feel free to use my promo code Pizza Party. You get $25 off your first booking. Live it up. Okay, cool. So, tonight's topic, of course, is instruments. And for those of us who are new to instruments, let me just give a really quick overview. Instruments is a part of Xcode and allows you to profile your app. And what is profiling? Well, here's a really just quick explanation. Basically, you run your app in a profile scheme. Instruments then collects data, and then Instruments will then present that data in an easily consumable way. It's pretty awesome. It can give you a super deep insight on performance and behavior of your app. It shows weaknesses, and it shows your strengths. And Instruments gives us a lot of different templates we can use to measure our app. Things like energy consumption or network usage. But tonight, because we have limited time, I'm going to only show you guys 3 of them. And so the first one we're going to look at is we're going to look at the core animation template. And we're going to fix some scrolling problems. Second off, we're going to move on to the allocations template. We have some memory problems to fix. And lastly, we're going to use a blank template, and we're going to actually write our own DTrace static probe, and we're going to measure some app behavior. So, awesome. A couple more notes about tonight. So tonight, I wrote 3 small apps. And I did this because I really think that Instruments is best demonstrated with practical examples. The point of this talk is to show you how you can start to find problems in your app using Instruments. Instruments is a very powerful and feature-rich tool, so we're really only going to scratch the surface of using Instruments. I should emphasize that this talk is not going to be a deep dive into the actual underlying problems. Like someone could spend many, many hours talking about how to get perfect scrolling. And I think it's just probably out of the scope of this talk to go really into depth, but we will talk about some stuff that will help out, of course. And the demo apps I wrote, they're going to be simple problems with simple solutions. The apps that everyone here works on their daily jobs are probably a lot more complicated, and the problems going to be a lot harder. So it's not going to be quite as easy as it is tonight, but don't worry, it will be okay. So let's dive right in. Let's talk about scrolling performance. Sorry, actually, like just because I'm doing a talk, I'm starting to get sick because I think that's like the law of doing talks. So, figures. Okay, so for my first app that I wrote tonight, just as a demo app, what it does is it shows you pictures of cats alongside quotes from the Magna Carta, and it's called Catacarta. Cool. So it looks like here, you got a picture of a cat. This is a UI table view here. You got this great document, this text from 1215. It's awesome. So cool. So Catacarta is a Swift app. A single UI table view controller. Images are part of the bundle, so they're just in XC assets. And the Magna Carta quotes are just read from a JSON file, also in the bundle. So there's no network connections, everything's local. And in order to make this a really, really good demo about fixing scrolling performance, this is intentionally the worst code I've ever written. So just fair warning. So cool, so let's see how this app runs. So, by the way, so I pre-recorded all these videos so you don't have to like painfully watch me like try to do this live, because that probably wouldn't work so well. So let me just play this here. So this is the app here. We are running it. Cool. Now you can't see my finger touches, but I'm actually scrolling. I'm scrolling still scrolling, but nothing's happening, of course. Still scrolling. Wait for it. Wait, there. Here we go again. Oh, still. Oh, nope. Okay, scrolling still. Scrolling. We're trying. And boom, we reached the bottom. So after we did that, I mean, I'm sure everyone would probably feel the same way, like I did. Ouch. This app, as it is today, right now, is unusable. So we have a problem. And what can we do? Well, maybe do we just start commenting out random lines? Do we put a bunch of breakpoints in a slog? Do we just say F it and just say git reset hard and just start over? Or do you tweet how much you hate Xcode, because it's probably Apple's fault, right? So don't do this. Don't do this. Please don't do this. But for this guy, go ahead, do it. It'll probably make you feel better anyway. Instead, we have a really obvious solution, and I'm sure you all know it because you're at this talk. We're going to use instruments. So let's show you how we can profile this terribly scrolling app. So here we go. And for those of you who haven't profiled before, it's pretty simple. What you do is you go up to the profile menu, and you say build. Okay, I select build, or profile rather. Oops. Cool. And then it's going to open instruments and open the template chooser. I'm going to choose the core animation template. And it's going to open instruments, and we're going to resize this here. Okay, cool. So let's do a baseline profile. We already know the app scroll is bad, but let's see what's our trouble areas of what we need to fix. So here we go. So I'm going to just record. I'm going to do again, do the scrolling. The thing's not working well at all. Okay. And cool. So we have a little baseline here. Awesome. So I want to just take a look at our numbers that we have right now. As we already know, our numbers are pretty bad. So these are the frames per second that we're getting from scrolling. Just as a point of measure, what we want to be getting is 60, or as close to 60 as possible, like 50s, high 50s. We're getting a lot of zeros, which means that's the opposite of good. That's really, really bad. So we have a lot of work to do. So let's see what we can see why this is scrolling so poorly. So what we're going to do is we're going to switch over to this time profiler instrument right below here. Cool. And what the time profiler does is it records the stack trace. So every 100 milliseconds or so, it's going to actually just record what's on the stack trace. And from there, it can tell you how much time is being spent in each method. Okay. And now, let's just expand our list of symbols. Here's a little trick in instruments. What you can do is you can hold down Option, and you can tap that side arrow right there. Okay, cool. And we get this big, long list of symbols. Okay. So, as we're looking at this list has a lot of stuff on here. I'm scrolling down and this is really complicated. Our app is literally 3 Swift classes. Literally, I wrote this in 2 hours. Why is there so much stuff on here? This is terrible. So this is not too useful for us, and this is information overload. So let's filter this stuff down. So what we're going to do is we're going to go over to this right sidebar over here. And what we're going to do is we're going to click that gear icon up there. And we're going to do 2 things. The first thing we're going to do is we're going to hide system libraries. Peace. Okay. Then next, we are going to separate by thread. And awesome. So then, let's go back, and now we have a much more manageable list. So once again, Let me expand them. I'm going to do one last thing too. I'm going to filter down using time. I'm going to hold down the shift key up here on the graph, and I'm going to choose a time region about when we were scrolling. So cool. Awesome. Okay, so now we can kind of dive deep into what's going wrong here. So let's just take a look. Okay, so as I'm scrolling, whoa, it looks like I'm spending 79% of our time in self-erode index path. That's probably not good. Well, let's see what's going on in there. And the cool thing about instruments and time profile, you just double tap the symbol name, and boom, you get jumping right to the code. Okay, so you can kind of see what's going on here. Okay, we get a cell, we configure it, and whoa, then we're making this quote generator object every single time. We're getting a random attributed quote. Well, that can't be good. Let's dive deeper. So let's now look at this quote generator thing. Okay, so we read it in a file, then we parse it, and we do this all in the main thread every single time for every single cell. That's not good. So obviously right now, you're probably thinking mistakes are made, and I personally made some very poor engineering decisions. And like here's a short list of stuff I did wrong. I did too much work in the main thread. I'm not reusing objects. I'm not even caching anything. But there's actually like a light at the end of the tunnel. Is that we know exactly what our problems are now. We didn't have to guess. We didn't make wild assumptions. We had a problem. We profiled our app, and then we collected data, and now we know exactly what we need to fix. So let's talk about these fixes really quickly here. What I'm going to do. I'm going to do my first pass of fixes. First, I'm going to stop creating this HT quote generator object every single time. I'm just going to create it once. And I'm going to store it as a property in my view controller. Next, I'm going to move my heavy lifting, my file input, my JSON parsing, my attributed string creation off the main thread. I can do that work on a background thread. I can dispatch it back to the main thread when I'm done. I'm not going to be blocking any user interaction or UI. That'll be a much better user experience. And I just want to reemphasize, though, that list I got wasn't guessing. It wasn't just like me being like, well, I think this is what's wrong. I just, we saved time. We profiled our app. And we started by attacking the most expensive operations that are blocking scrolling. Not making a bunch of guesses. And it's pretty awesome. This is why instruments is like pretty fun. So the team went out for like a beer or something, and I was like the guy who was like, okay, I'll stay behind. So I did like the initial scrolling, I did all those fixes I mentioned. And here we go. Go back to core animation, reprofile. And now, boom, as I scroll now, we actually have a scrolling app that's actually usable and actually, probably could get VC funding or something now. So it's pretty useful now. Sweet. So I should do a quick interlude though about this. You notice I said performance pass number 1 earlier. Instruments is not a magic bullet. You can't just profile and then install some package to fix your scrolling. You are going to need, instruments just simply gives you the data in an easily consumable way. You're going to need to interpret that data and then, as engineers, make meaningful changes to your code. And every app is different, and all apps won't have the same problems. And normally what this is going to look like is your workflow is going to be something like profile, modify, then test. And then you have to repeat it again, and this might take hours or even days, again and again, and then finally you can ship it and have a beer. So let's move on. Let's talk about memory in apps and how instruments can help us with some memory problems. Now, with memory, I like to think of them as, in iOS apps, as being the silent killer. And let me explain why. So this is a graph of memory usage. And let's just say this is like a user just opened your app. Cool. Like things are looking good, memory usage is low. And they do a few things, click a few buttons, we push a few view controllers on a stack, but you were a little bit sloppy in some cases, and you didn't really manage it so well. No harm, no foul, like they're on a 6S, they have tons of RAM, it's all good. But then, you were a little more sloppy, more and more. And it grows. But at this point, the user's engaged, they're having a good time. Like your app might be a store, and they have their credit card in hand, they're ready to convert, and then suddenly, boom, you hit the point, and iOS is like, nope. And then iOS terminates your app, And the user gets no message, no anything. To the user, it looks like your app just crashed. But the worst part is your crash reporting service is not even reported as a crash. It sucks. Memory problems are not fun. So let's see how instruments can help with this. I have another app I wrote. This app is kind of really, really boring. It's simply a UI table view controller with 2 options. However, one of the complaints we've been getting from users is the app is crashing after the user for a few minutes. And to me, that sounds like we have a memory issue. So let's fire up instruments and let's start profiling the app. So, okay, do the same thing, I'm gonna profile. This time I'm gonna select the allocations template. Awesome. So let's run this again. Launch our app. And so just a quick note on this. For this, just for the purpose of demo, we're gonna pay attention to 2 columns. The persistent column and the transient column. The persistent column, and these, by the way, over here are the type of object it is. So the persistent objects represent every object that's currently in memory. Transient objects are all the objects that are no longer in memory. As a general rule of thumb, if this number is a lot higher than this number, like if this is like 20 and this is 0, you probably have a problem. But we'll show more and more how that is a problem. But also you notice another thing too we have a problem of, is that once again, like the time profile earlier, this is a lot of data. Like look how simple this app is and look how much crap we have on here. So it's pretty hard to get any kind of useful data out here. It's data overload. So like the time profiler, we need to filter it down. So what we're gonna do is we're gonna go over to the right toolbar again, like we did before. Okay, cool. And this one has kind of a cool tool. It's this recorded types thing here. And what we can do is that we can record specific types of objects. So right now it's recording everything. So I'm gonna disable this, and all my classes are prefixed with MEM for this example. So I'm gonna select that. You can add something, you can add something like DOS as a prefix, or you can even do deeper filtering, like you want to say see only view controllers, or something that ends in a particular name. Pretty powerful. So let's profile again. Look at that, much better. There we go. Okay, so let me just go over what we have in this app, this really simple app. So first we have the app delegate, which we have one of. Then we have menu options. This is just like a menu, this is a model object representing a menu item on the table view. We have 2 cells, so that makes sense, 2 of those models in memory. And we have the menu view controller, that has a table view, and one of those. So pretty simple. So let's now try to use this app. I'm gonna use this app, and I get Rickroll. Awesome. Okay, so great. And now, as we see, the memory usage has gone up. So we push on the details view controller, so we have one of those. And apparently there's 7 Rickroll views, because I guess 1 wasn't good enough. So cool. So let's press back. And well, that was kind of weird. Everything just stayed the same. It's probably Xcode. You're perfect. You're a gem. You didn't do anything wrong. Let's try again. Let's see what happens. Let me push again. And then, whoa, now it just doubled. Okay, no, you're not a snowflake. You did something wrong. Okay, so, and let's just go over and over again. And it looks like, so let's look at our problems right now. The first thing to look at is your graph. This is your memory usage in the app. And you see it's just going up and up and up and up, but never down. That's very, very bad. Notice my transient column is all zeros. We are never releasing the details view controller or the Rickroll views. So let's dig into the problem and let's see what's causing this, and let's see what's happening. So I am going to go to look at this details view controller, use disclosure triangle, and let me look at who's responsible for calling it. Okay, so it's this table view select row and index path. Let's jump over to Xcode, take a look. So quickly looking over this, Okay, looks okay. This looks pretty standard. Don't see anything that could be a problem here. Okay, let's dig deeper though. Let's see who's calling all these Rickroll views. And it's this details view controller Rickroll user. Okay, so jump to Xcode again. Awesome. And here's my Rickroll user method here. So now I got some questionable casts, of course, but it's looking, well, actually I see one line. This line right here. Let me just double check and see how I declare this delegate. And it's just command click it and boom, we have a problem here. Yep. Ouch. So let me just explain exactly what happened for those of you guys who weren't following. We had a menu view controller, and the user taps on order chicken wings. The navigation controller then pushes that detail view controller on the navigation stack. During the view loading process on the detail view controller, the detail view controller adds this Rickroll view as a subview to its view. Then, that instance of the Rickroll view, the same one that was just added as a subview to the detail view controller, sets its strong delegate property to the details view controller. We have made a retain cycle. Then the user taps back. The navigation controller pops that view controller and removes it from its array of view controllers. But since that Rickroll view also has a strong reference to the detail view controller, the detail view controller retain count is not 0, and therefore it's not released. Thus, it leaks, and it's inaccessible, and it's deadlocked. And then this will happen again, and again, and again, until the app is terminated by iOS because you're using too much RAM. Never gonna give you up indeed. So, the fix for this is super, super quick. Obviously, and many of you probably know this already, is we're just gonna switch this from strong to weak. Cool. And now, let's reprofile and see what happens. Okay, cool. I'm doing this and go back. My memory usage goes down. I press, order chicken wings again. Goes up, then back again. Up and then down. This is looking good. This is looking very good. And cool. So now we can see our graph. We had times when we had the Rickroll view there, losing a lot more RAM. But as soon as the user pressed back, we released everything. Then went back up, release, back up, release. This is what we want to see. This is very healthy. But I'm sure at this point, though, especially the more experienced people, are probably thinking strong delegate. Really? Like, that's your best example? But I actually really, really like this example because it shows how just a single keyword in your app can wreak havoc to your memory footprint. Now, like an app like this like table view, detail view type view, it's kind of a joke, right? But let's say your view hierarchy was something like this, with dozens of subviews, and maybe even hundreds, and you have delegates all over the place. One wrong keyword that goes by a PR, that goes by a lot of stuff, could wreak havoc down your app and cause bad performance down the funnel or down something even worse. So you just have to use instruments, and you just have to just find the stuff because it's really important to try to find. But most of you are probably going to have problems around blocks or closures for you cool Swift people. But I'm all good, right? Xcode does that yellow thing. It's cool. This might be captured strongly. Well, not always. Here, I have an object that has a stored block property. I create that object. In that block property, I capture self. Then I store that property as a property in self. Right there, I've just retained self, and I'm screwed. But thankfully, the same principles that I just did to find that strong delegate is the same way we can hunt down these kind of problems. The same principles apply. We use the allocations template. We notice that the MEM better details view controller is never transient, and we can fix it. And the fix isn't quite as easy, but it's almost as easy. And you can do this, or even Swift has it built into the language with capture lists, which is pretty cool. So yeah, those are memory issues. Now let's jump over to our last thing of the night, which are custom instruments. So instruments gives us a lot of great templates, a lot of really, really cool stuff. But let's say you want to measure something a little bit different in your app. Let's say none of these templates that Apple provides quite works. Can you make your own? Yep, it turns out you can. So let's talk about first a little, very, very brief overview of what powers instruments. And that's pretty simple. It's DTrace. And what's DTrace? It dates back to Solaris, which was a Sun Microsystems OS. It's a dynamic tracing framework. It was added back to the Mac in 10.5 Leopard. And so how do I use it? DTrace probes. So you write probes, which are like sensors you put in your code. And there's a language to use it. It's the D programming language. It's like a scripting language. It's very similar to C. And it's cool because you can leave these probes in your code, and they will have no performance cost just for leaving them there. They only get that cost if the DTrace probe is activated. There are caveats with that, but for the most part, you can leave them in your code and things should be fine. And DTrace is super, super advanced and very comprehensive. Tonight, we're going to be doing the equivalent of like a hello world when we write this, so fair warning, like we're merely scratching the surface of what DTrace has. It's super, super powerful and really cool. But there are some limitations on iOS. So actually, DTrace is only available on iOS 10. You can only really run custom DTrace probes on iOS devices, despite the fact that that's how Apple does it with all the instruments you have. But there is some good news. Because the iOS simulator is not an emulator and it actually compiles down to x86, we can use the simulator to run this stuff. So to run our custom DTrace probe. So let's build a simple instrument to measure an app's behavior. So for the last app I wrote tonight, this app is Tinder, but for burritos, I'm calling it Binder. So Binder is an Objective-C app. It's just a single view controller, and burritos are awesome. Just wanted to say that. And we're going to do something really super, super simple. We're going to measure every single time we log analytics. So here is our analytic call. It lives in some singleton somewhere, and pretty much it takes a string name, and then an endless dictionary of params. Pretty cool, pretty simple. And what I want to do is I want to track an instrument's every time this fires, and what I want is I want the event name, and I want the number of keys in that params dictionary. Okay, so just using a DTrace static probe and instruments, I can do just that. So let's start. So the first thing we need to do is we need to create a new file. So what we're going to do, we're going to go to File, New, then do Other, select Empty, and I'm going to call this file analyticprovider.d. That's D as in Doug. And cool. I open it up. So the next step we need to do is we need to write a provider. Now providers are like groups for probes. So let's make one called analytics. And you can already tell this is kind of like a C-like programming language. It has some similarities. The next thing we're going to do is we're going to actually make our probe. We're going to make a probe called track analytic call. And it's going to take two parameters. It's going to take a string for the event and an integer for the number of events, or number of the parameters in that dictionary. So, cool. Pretty straightforward, pretty easy. Now, the next step we got to do is we just got to build the project. And it builds. Awesome. So what just happened here? Actually, Xcode did some magic for you, which is pretty amazing for Xcode. So what it did was it took that analytic provider I just did, and it turned it into a C header file. So let's import this header into our file. And it's going to be the same name as the file we just created, but just with an H. And let's take a look at this header. Okay, this looks pretty complicated and above my pay grade, but it's fine. Okay, but what it did was it created really like two important macros. The first one was this analytic track analytic call enabled. What this does is this checks if that DTrace probe is enabled. Cool. Then it created this second one, which is analytic track analytic call arc0 arc1, which is directly from that probe we wrote. It turned this into a macro C function. Awesome. So let's add this enable check into our code. So I can wrap it in an ordinary plain old if statement. Awesome. Now let's call the probe. And for arg0, do the event name. And then params, I do all keys count. Boom. And let me just add a cast to make Xcode happy. Awesome. Cool. So let's profile. Okay, we're going to select blank. And then we're going to, after we do this, we're going to go to instrument, build new instrument. Cool. Okay, step 1, let's name it. Now let's go down here and let's name our probe. We're going to select custom type. And for the module, we're going to leave provider blank, but we're going to use Binder, the app name, as the module. We'll keep function blank. And then probe name, we're going to use the probe name that we defined earlier. Awesome. So let's scroll down. Cool. So let's record arg0 from our function. And that was event name string. So I say arg0, event name. Let me add one more parameter. I'm going to do arg1, which was number of parameters, which was an integer. Awesome. Okay, so now we have this little instrument set up. So let's build it and let's see how it works. Awesome. So now every time I tap a button, you see that it's giving me the event name, the number of parameters, and then the caller who called it. And it's pretty simple, pretty whirly, but it can be a lot useful depending on your app. And you can sort it, you can export it to CSV, you can do whatever you want with it. It's pretty sweet. And you're probably thinking, okay, this is great. I want to share this. I want to send this to my team. Write a blog post or something about it. Great. Let's save this. Got some kind of bad news for you guys. So there's a bug in Xcode. So I go to save and just beeps at you. You straight do this, and then you try to quit, and instruments won't quit at all. And you actually just have to force quit and just say, well, I tried, And yeah, so another ouch. There is a radar about it. I mean, this is not a Swift grammar change in the documentation, so I don't know what the priority is, but hopefully it will get taken care of one day. But seriously, this stuff is really, really cool, and I think Instruments is a really, really fun time, and a really, really powerful tool that you can use to make really great apps. Before I go, just have a few recommended resources. The first one is if you're going to DubDub, and there's a talk about instruments, make sure you go. They are always some of the best talks you will hear. I've never left one of those talks being man, that was a waste of time. If you see that on the schedule, go. I promise you they are the best. Big Nerd Ranch has a lot of really, really great in-depth articles about DTrace. As I said, I scratched really the surface about what DTrace is. The first 3 paragraphs of the blog post blow me away. So they're awesome, really, really good. And of course, Obsi.io has some great articles about DTrace and a lot of other stuff too. I'm going to post a link. I'm going to give a gist of what I think some really good resources are. But yeah, so thanks a lot. You can follow me on Twitter at Doug Suriano. And yeah, any questions? I can officially drink beer now, so it's cool.
Question? Well, yeah, what's up? You mentioned using prefixes for finding classes that are yours, but in Swiftland there really aren't. You don't really have prefixes generally.
That's right.
Do you have a recommendation for how to do that?
Honestly, at least at HT right now, we still put prefixes on Swift classes, which I know is knowing what's in here, right? Oh yeah, I'm sorry. The repeated question, I forgot to repeat the question, was that in Swift, in Objective-C land, we used to prefix our methods. That was our what we did. But in Swift land, now we don't do that as often, and we can't. It's just not part of the language per se. So what do we do now? I'm not sure actually, to tell you the truth, what the best practice with this is. I'm pretty sure though Instruments is going to show as a module name, the full module name, so you'd be able to probably filter it down by module name, but I would have to double check it. Generally, most of my profiling with Swift apps is in a mixed Objective-C Swift app, and that tends to mess everything up completely. So I'm sure it's easier in pure Swift apps, but in HT, as I said, we still use class prefixes on Swift classes just because it blends better with the project.
Thanks.
So you showed an example of a memory leak, and you showed like how to fix it with the keyword. Changing one of the keywords. Can you write unit tests to detect that, or is it only by profiling that you see those types of problems?
That's a good question. Can you can you detect and like see if something's strong or weak property? Does anyone know? Actually, I'm not sure. Actually, it's a good question. I maybe there's something cool in the runtime. That runtime is pretty cool. So I'm not sure actually. Honestly, that would be very interesting because if you could write unit tests, that would be a great way, and that you could avoid profiling for sure. Sure.
So even though you can't, you can only run this on a simulator. Say you wanted to do a long-term test and basically log all the DTrace information. How would you go about doing that, or can you even do that?
As far as from like the actual device, or
from the simulator, right? Say I wanted to run the simulator for like 8 hours. Right? Is there a way of like capturing that information, or is that pretty much?
You probably could, but I probably would guess that you would probably be better served by actually just not using instruments. So really, instruments provides a nice interface with DTrace. So you would probably be better served by like writing like a Python script or something like that, long running that you can run in the background, versus trying to like have a GUI running and all that stuff. Because I imagine 8 hours of instruments running, you're consuming a lot of resources. It's displaying a table view of all that data. So I would imagine that you'd be better served by a DTrace script that's backed by some kind of runner script that can record data in a better way, and an easily more loggable way too.
Okay, so a lot of people who get into instruments, they usually do it when they're having a nightmare. Otherwise, you don't want to use instruments. Do you have any story from top of your mind in your career where instruments saved your life? Something like that?
Not really like saved my life per se, but no, actually, so I mean, there's really recently at HT, we took our app from, we used to have the old school way, when back in the day you had a phone app and a tablet app, right? And we had you had a root view controller, and then you had two subclasses, phone and tablet. And they were completely different apps, really, like different UIs and all that stuff. So what we did recently is we moved away and we made the app a universal app. And we added rotation to the HT tablet app so you could do the multitasking. And we had memory problems like crazy. Like when you only assume you're going to lay out your app once or lay out something one time, and suddenly then you add that a user could like rotate and then maybe even do multitasking and trigger all these layout calls. It was crazy the amount of crap we found. And during those times, like it was like finding those retaining cycles, all that stuff was very, very valuable, and it really like helped to shift that feature. And scrolling performance, I swear, like once, at least a couple times a quarter, we get a C level being like, this app's scrolling poorly, and like you just got you go in instruments, you fire up, and you can give data about what's going on. So, yeah, I guess those are my two examples.
I have the opposite question. Would you recommend doing instruments on an app that seems to be working just fine? Like, from your experience, do you find interesting things?
And the question, because I've been totally messing this up, actually was, would you recommend profiling the app every single time, or like a lot more often when the app's doing fine? I'm not sure. It really depends on your own what's going on. If you have nothing to do one day, let's say, and your Jira board is completely empty, there's no PM hip chatting you about something or anything like that, knock yourself out. I think it's a bit with time. But honestly, though a lot of stuff like memory stuff isn't a problem until it's really, really, really a problem, right? You can be leaking memory all over the place. But if you're only leaking a few things, no harm, no foul. Everything's fine. So for me, I think it's if you think your app's doing really, really well, I would definitely just recommend, if you have some downtime, take a half hour and just go through and just give a health check on everything. It wouldn't hurt.
Is there a way to run instruments with UI tests, or while you're running unit tests in a hosted app or anything like that, and sort of look at the output and look for problems?
Yes, I believe, because I think because all the JavaScript automation stuff is part of instruments. So I'm pretty sure you can run the JavaScript automation tests alongside. And the question was, can you run side unit tests and instruments at the same time. I believe there are ways to do it. I'm not exactly sure because I haven't done it before, but I'm pretty sure you can probably build an instrument that can do that kind of stuff.
What do you use to detect evictions by Watchdog in your app in the wild?
Oh, like in the wild, like out. We have a couple of tricks that we do at HD because I mean, like our crash reporting services won't show that stuff up. We have some things that like we set some like a static bool, and if that's not flagged, like if it, and we flag that at the end of whatever the app delegate method for leaving the app is, did leave or did terminate or something. Yeah, one of the good enough, close enough for me. And so we do kind of stuff like that, so we can kind of look at those numbers, but that's not always a really accurate number of like those problems. So it's hard, and we've talked to some of our partners about that, especially our crash providing services, and it can be a challenge to get those numbers.
What's the source of inaccuracies with that strategy? I do something similar.
I guess it's not really a source of inaccuracy. It's just like you don't know, right? Like it could be, in theory, everything should be good, but I'm not 100% sure. I guess I just don't trust my own code per se. Is what I'm trying to say. That sometimes I would much prefer a system framework to give you that clear message of what happened versus just kind of having to guess it. Cool.
All right, let's give Doug a round of applause. All right, just a couple of announcements. On the NS Meetup Twitter account and NSMeetup.com, we have links to the slides. We also recorded this event, and we'll have a screen capture of everything Doug showed on the screen tonight. So if you want to watch the instruments window up close, all that, we'll have it posted on the YouTube channel. I'll make sure to tweet it out. What else? Oh, yeah. If you're interested in speaking or you're interested in hearing more about a particular topic, please come find me. My name's Steve. I'm the organizer, and we'd love to have you speak or have someone talk more about a topic that you're interested in. That's what this group's about. So if you have any questions, concerns, things you want to hear about, please let me know. There's plenty of beer. We're here till 9, so enjoy yourself. Thanks, guys.